Number 3, zinc is held by electrostatic forces of attraction between particles. What are they talking about? They're talking about the nucleus or the protons, because they are obviously positive, and the negative particles, of course, electrons, which are negative. When they say electrostatic forces, they're talking about the force of attraction between positive and negative charges. Okay, we've got to name this kind of bonding of zinc is a metal, and so this is metallic bonding. On to part 2. Name the two types of particles held together by the bonding in AI. We're talking about electrons, and the nucleus is made of protons, but those protons make up positive ions. That's what we need to write here. Because of course, in the nucleus, there is not just protons, there are also neutrons. So they're talking about all of these positive ions, so it's made up of many nucleuses, which we would consider positive ions, and then the delocalized electrons, which are negative, are attracted to each other, keeping the zinc atoms bonded to one another. Okay, the next one, name the type of particle whose movement allows zinc to conduct electricity. Well, we've just been talking about the structure. The only thing that moves are the electrons. Zinc is present in alloys such as brass. State the meaning of the term alloy. An alloy, we've got to write down, is a mixture. That just means it's not chemically bonded. So that means the zinc is not chemically bonded within the brass. It is just physically bonded, which just means mixed together, smushed together until it made a mass. And these can be separated using physical separation, not filtration unfortunately, because obviously these are not soluble, but they can be separated using melting, and then difference of densities will make one of them float or sink. Name the substance that is present in brass other than zinc, and this is copper. So the thing that the zinc is physically bonded with is copper. So now we've got some steps of an experiment. So we've got zinc sulfate crystals are made by the reaction between zinc carbonate, dilute sulfuric acid, using the following steps. An excess of the powdered solid zinc carbonate is added to dilute sulfuric acid. Let's just write this out. So we've got zinc carbonate plus acid is going to make a salt, water, and carbon dioxide, as always, CO2. So excess zinc carbonate is separated, so using filtration, exactly. Aqueous zinc carbonate is heated until saturation. The saturation solution is allowed to cool and crystallize. The crystals are removed and dried. They've made crystals which are zinc sulfate, which is our salt. Give 2 observations which show that the zinc carbonate is in excess in step 1. So if zinc carbonate is in excess, that means it will stop dissolving. So it's not actually asking you to look in step 1, it's asking you what would happen in step 1 if it was in excess. So that means some of the solid would be left to be filtered out. And the second one is that also this reaction will stop because there will be no more sulfuric acid left to keep reacting with the zinc carbonate. So that means this carbon dioxide that we talked about earlier, the bubbling, will also stop because we've run out of the acid if this is in excess. On to part 2, name the filtrate in step 2. Okay, so they're talking about this up here. Excess zinc carbonate is separated. The filtrate is the thing that ends up going through the filter paper. So this is the solid and this is the filtrate. So what was left in the beaker? And this is zinc sulfate solution or aqueous zinc sulfate. And of course, the solid that was left of the excess zinc carbonate is known as the residue, just in case that comes up on another paper. The next one, name a compound other than zinc carbonate that can be added to dilute sulfuric acid to produce aqueous zinc sulfate in step 1. So unfortunately, zinc is not a reactive enough metal to be on its own, not reactive enough, which means we have to either choose zinc oxide, typically this is the one that students should remember better, or zinc hydroxide. Okay, state what is meant by the term saturated solution. This is just a solution that's at maximum concentration of the solute, so in this case the zinc sulfate, and this happens at a specific temperature. We have to add that just because at different temperatures the maximum concentration that can be dissolved in the water will change. So those are the 2 marks. Step 1 is repeated using large pieces of zinc carbonate. So this question is asking about large pieces. Typically they're asking about rate of reaction, and basically the bigger the chunks of anything, so compared to a powder, obviously when it's then added to the acid can get to all sides of each of these tiny dots, these tiny pieces of powder, compared to these larger pieces of zinc carbonate. So that means the rate of reaction will decrease because there is less surface area of larger pieces of any carbonate, any oxide, any metal. And we also need to talk about the less frequency of collisions of the molecules, for example particles of the acid with the zinc carbonate. On to the next one, on to number 6. Hydrated crystals form in step 4. State what is meant by the term hydrated. Again, another one, a good one for a flashcard. So this means chemically bonded with water. This one comes up a lot.